that customer can also consider that how much energy bill saving will be there, but most of the benefits will come to the DSO and TSO. So what the benefits of the TSO and TSO will be there, they can work on energy management system, and that energy management system due to the virtual power plant will help them to overcome the fluctuation of renewable energy sources and to improve the grid functionality, right, for doing energy efficient operation, and of course the collected data will be used for further planning of energy network. Now I have given you some information, objectives, how the system works. So based on that, this project or this work have been divided in different work packages also. So here, first work package, it was related to the project management, and my role in this project, it was as a technical manager. And now here you can see that how the 12 partners from 4 countries with user participation and the pilots, how technically it is challenging also. I will explain you what technical challenges which we do. In work package 3, we did overall system design and specification. In work package 4, we did development of system infrastructure. In work package, we did development of aggregated intelligence. In work package 6, system integration. Work package 7, pilot testing and system validation. But at the same time, whatever the results which we are going to get, those results which we need to disseminate to the stakeholders and the common public also, because there is a public participation and this project is funded by the public money. So we need to have exploitation and dissemination work package and to have the regular engagement from the stakeholders also. Okay. Then it is very important that all this we are using the ICT infrastructure. So work package 8 covered the system safety, data privacy, user privacy also, and going to impact the business model. So it has been covered into the work package 9, how we have to develop the new business models also. Now I am going to give a task that based on this front end and the back end system, right, how you will develop integration of both, what data have been collected from the front end system to the back end system, and what data have been provided from the back end system to the front end system. So I am giving you, let's say, 15 minutes time, and please prepare one flowchart or architecture where we need to integrate front end and back end system. Right? So after 15 minutes, then I will share you the system architecture, how we develop and how your thinking are getting matched with that architecture. Okay? So now please have 15 minutes time, right, to develop the architecture. Maybe I should go back here, in which we are trying to integrate this front-end system and the back-end system. I am not asking you to develop some programming, because it is very difficult to do the programming at this moment, because we are having so many different components. Okay? But at a very high level, if we have to develop the system architecture, and I believe that most of you are quite very good in that one, because you have the many of you are having the computer engineering background. So considering this slide into account, how you will develop the system architecture for integrating front end and the back end system. Those who are sitting back, maybe it may not be visible for them, maybe they can go front and take the photo, or maybe just go and read that and then work on developing the system architecture for 15 minutes. Okay, then I will share with you how we develop that one, because your participation is also very important. I will provide some little bit information also. So here we have home energy management gateway. Okay, so this home energy management gateway in selected, let's say 100 houses in Norway and 100 houses in Switzerland. So that home energy management gateway, it is working as a bidirectional. Okay, and in this home energy management gateway, collecting the information from selected non-critical power appliances which are going to contribute in the demand response program. Okay, then that information from this front-end system is communicated back to the back-end system. So back-end system, that is a virtual power plant. In that back-end system, we are collecting the information through this home energy management gateway from the individual, right? How the load profile is happening, how the consumption profile, not only the selected loads, but overall also, because that overall load profile is also going to be useful for developing demand side management scenario. And then that information what I have mentioned here, then it has to be aggregated here. Based on that aggregation, right, then of course this backend system has to take into account some constraints. Those constraints will be feeder level, distribution level, because we cannot change the demand above the limits, right? So some specification of the limits is going to be there. But at the same time, if we have some renewables here, so renewables is going to get the top priority also. But then accordingly, this backend system or the virtual power plant system has to take into account limitation of the conventional power plants also. Okay, all considering all this information based on the forecasting techniques, then this backend system is going to generate some demand side management scenario. So then that demand side management scenario is going to be communicated back to this aggregated loads of that area. Okay, and then it is going to be used by this front end system in shifting the operation of the loops. So this demand side management scenario which might have been generated this backend system, they may valid for next 25 minutes, 30 minutes or 1 hour, and at the same time then that information at the backend system based on overall energy consumption profile and like that can be used by DSO in generating real-time pricing signals for next 24 hours also. So then that next 24-hour price signals is also going to be useful in the front-end system for shifting the operation of non-critical loads also. Then user can decide or put some preferences also. So now considering all this point into account and taking into account your background at the postgraduate level, I expect that you may be in a position to provide me some system architecture. Okay, don't worry about that, how you will make it. Okay, try, and then I am going to share how we develop the system architecture for that. Here I mentioned sensors, actuators, etc., etc. So those points are also very important, because on the front end system, when we shift the operation of the selected non-critical load, okay, so let's say in this case we have the thermal inertia based load or the boiler load, so that operating parameters of the load is also going to be important. So what are those operating parameters? For example, minimum and maximum operating temperature, because always that thermal load we have to keep it at the minimum temperature, otherwise that boiler functioning from the health and safety condition point of view will not be good. So that just I have given you one example. If in case of boiler, if we select the electric vehicle charging load, so we have to see that how we have to put the minimum reserve charging also. So all these points I want to see that how you can include in your system architecture, okay, for developing such type of system. But the same thing can be used for industrial applications also. Two of my PhD students, they are using the same approach for industrial application. One student, he has completed his industrial PhD in shifting the load of supermarket store, in which we have both critical and non-critical loads. Then he used thermal storage and the battery storage, integration of the renewables also, and he used machine learning algorithms for developing the scenarios for shifting the operation, and his PhD thesis is publicly available. Okay, I will share that thesis with you. And then one student, he is still continuing his PhD work, but he already published some paper. He used the scenario of the industrial case of cheese factory. Like in the cheese factory, then we have the both critical and non-critical load, mainly the thermal load and the cooling loads. And then he used physics-based modeling for shifting the load. And the earlier candidate, which I mentioned that he took the case of industrial supermarket case, he used machine learning based approach for demand response system. So now here, what the task which I have given you for this typical case, how you are thinking based on the lectures or based on the discussion, right, how you will develop the system architecture for that one at very high level. You can say urban, rural, whatever, right? So depending on the current locations, conditions and locations. And those houses or those cities, they are participating. So basically, our objective is on the demand response system. And within the demand response system, if we go back here, our objective is improve the load factor, shift the operation. And shifting the operation, we want to use this domestic. Correct? So all the loads we cannot shift. We have to select non-critical but power also. So that we need to identify. That we at the standard system. But you see, daily or all the time the curve may not be like this. Because we are having the real-time pricing also. And we are integrating the renewables also. Correct? And we have, renewable has to get the petrol, so this is not with the dynamic. So that's why we use word non-critical. right? So this, and then here that information then, let's say everything should be automatic, huh? Otherwise it will not work. So then based on that, how then you have to take into account the constraints of the loads also. And then all this information then in aggregated manner connected at the backend system. You see all houses in one. And then this backend system, that we call it as a virtual power plant. Then based on this one, of course real time connecting, and it has a historical data also for next classic. Based on that, may get the information about the forecasting also, how the load may vary. Then may get the information of the forecasting of the renewables also. Then, okay, and then of course conventional power plant production and information will also be available here at the virtual power plant. But then when we have the houses here, here's the information about the capacity of these lines also. So that also need to be taken into account. Then based on that, this backend system will create some demand side management scenarios for next 1 hour or 2 hours, whatever. And then that will be communicated back to the backend system, to the home energy management gateway. And then this gateway is going to communicate to the local load. Right? So you see, of course, no, we have to think from the system engineering point of view always system. Of course, no, weather parameters is going to impact renewable prediction.
In terms of renewable, you have to think about weather parameters.
Then other parameters is also very important that we will consider cover maybe in the next lecture or something. So that weather parameter is going to impact the energy consumption profile of this process also. Correct? Because if we are taking that house as a load, so inside how much heating demand is going to be required, that will based on outside weather parameters. If it is too cold outside, we need more energy. If it is too hot outside, or basically the balancing, or accordingly the energy consumption profile will change. And we are taking the thermal load here, that's why. So thermal load is going to be based on weather parameters. With that, accordingly the energy consumption of it. So how, let's say, if you have given as a task of it as a system architecture, right? How you will develop that? You got my point? So, I mean, we can develop the modeling for each and every components. Okay? Then, when we want to develop the modeling for each and every component, then we need all technical characteristics, no? Operational characteristics and everything. Then it requires a lot of time, and then we have to go through the literature review and find out, then, or we have to refer the manufacturer's manual also to see everything. But now, because we are at the learning stage and high level different discipline, so system architecture I think it is much better. So let's try. Okay? So that may be your assignment. Maybe then you can say that yes, we participated into the examination. Okay? then you can say that yes, participants are participated in the examination also. It's up to you. Okay? If you want to. You can make maybe on one page, okay, or whatever you feel comfortable. Then it may be much better that maybe you can work in the groups also, or maybe 2 people in one group or one, and then I will request that group or that person to share their ideas with the audience or participants also, what they think, okay? Then that will be more interactive, and then I will yeah, okay? This is a typical example of this project is a typical example of our or typical case study, maybe I can say, for our course also. Okay, because our course is use of machine learning for sustainable technology development. We are trying to do the sustainability. We are trying to do integrate some machine learning tools and like that. Okay, and you are learning that one. So then we have to see that how you are going to integrate that and how your learning is going to be there. Of course, I am going to show you how we develop the system architecture. You can take maybe 15 minutes more time, but I am going to request as a group some people to present that what they thought. Okay? So then that will be much more interactive for me also and for you also. One more thing, depending on your thinking also, here when we are talking about this individual houses, okay? So here you see these houses, they may have the building integrated photovoltaic system also. So that production of the building integrated photovoltaic system is also going to impact the overall energy consumption here. Correct? So that may be impacting in deciding the demand side management scenario from the backend system here. So in your thinking at the system level, you can include that production of building integrated photovoltaic system, which is going to depend on local weather parameters. I mean, if we think overall this objective, it looks like a very simple objective, shift the operation. But when we want to do the implementation into the field using centralized approach with integration of the back end and the front end, how complicated it is going to be. Another interesting thing, when we are talking about here home energy management gateway, which is the size of the mobile, let's say, it is going to have its own operating platform also. And time to time, this operating platform, in this case it was Ogema, we need to upgrade also, right? As we always get our mobile software updates and so on and so forth, taking into account the security and privacy conditions, everything. So that functionality should also be there.
What you have to look at is the customer. Customer in the sense, here my understanding is, I have taken the example as how to predict the energy consumption by using machine learning. In that, that is my thought. Based on that thought, I'm going to present here. First thing is customer. What I have assumed is, we are using, see here in home automation or anywhere else, in that, I mean, energy consumption is in base, that will be there in rural area as well as in urban area. The energy, if we are using here, the customer, I have taken the profile management and monitoring is for rural area as well as urban area, how the energy is utilized. That is, that I have taken in the customer side. And then the energy, how much amount of energy it has been absorbed, I have taken the front end as home energy management. That can be sensed by means of, we have sensors, actuators and meters, and those things will be those things will get the information about the consumption by the household in the household applications. With the help of those data, we have to get the nearby weather information, because the data, home automation or whatever it may be, because we will be there in winter season as well as there in summer season. So because in winter season we may not use fans or air conditioner like that, but instead of that we may use heaters. So likewise we have to consider all the parameters. Along with that, weather data also we have to look into that. All those parameters we have to take it as a data. That with the help of those data, we have to go for the next process as backend system. With the help of those data, we have to go for machine learning process. In that machine learning process, sir has explained number of things about from the starting of the data set, and how do we want to remove that. That means we may have some missed values like that will be there, and then how do we want to consider those data, and then how do we want to fill up those data, that missing values, those things you have to do. And then you have to go for aggregation and then forecasting. Here the forecasting depends upon the application how we are choosing. We may go for the data, live data, or we may take for 1 month data or 1 day data as like that. So based on that, the data set, we may get it as live data, or we may get the data, that means that stored data, like as the European countries have that stored data, we may get the data set from those from those data set, and those data sets we may use machine learning algorithms. We have n number of machine learning algorithms as sir discussed. That algorithms we may implement, and from that implementation, and we may go for that prediction analysis we have to do. So from that prediction analysis we have to look for accuracy. That means which algorithm have given better accuracy, and from the overall assumption we have to look at the main thing as in this I have looked from, I have understand from this diagram is we may get the data in all the ranges, but you have to look at for the peak value. So where we got the peak value, so for that data we have to work out, and based that value we may obtain from the prediction. So based on the prediction analysis we may look for the energy system also. Here renewable energy sources plays a major role, and which type of renewable energy we are using, that is also very much important. So based upon the renewable energy source which we are using, here we may go for the analysis here.
Very good. So thank you. So she has briefed very nicely that how the different technical parameters need to be covered, and how the machine learning techniques can be used for this integration of front end and the back end system, right. So maybe in simple way, integration of the front end and back end system, but for making the decision at the back end system, the focus, if I understood correctly, was like to use the machine learning tools for defining or predicting demand side management scenario, which need to be communicated to the front end for shifting the operation of non-critical loads. And in that point she also mentioned that we need to consider about the renewable energy sources, because that is also going to be used into this flexibility component within the distributed network. Am I right? So anyone want to share? I mean, do you want to share something? Yeah, please come. Very good. So we can connect it your computer with SDMA. Yeah. Okay. It is very important to have your participation also, no? So how you are thinking, and then I will also get the idea that how you can work on such type of projects where we want to integrate, let us say, centralized approach for doing energy efficiency through demand side management. Okay. And then when we are using the centralized approach, then of course we need to use machine learning tools or AI tools for that. Please.
So, am I audible? So, based on my research and understanding, for renewable energy resources, I have made a small architecture, and it is based on my previous projects in my bachelor's and my master's, and till now whatever I researched, based on that I have made a small architecture. So as we all know, in future we are coming towards our energy resources are going to decrease day by day. So we are more focused towards renewable energy. So that's why I have selected few renewable energy sources as wind energy and solar energy and thermal energy and some biogases in my architecture, like so few renewable energy sources I have linked. But before this block, how the interface should be to the user. There may be many renewable energy sources, but how user can interact, and as sir said in previous lecture that there should be virtual platforms to organize our work, and how the data is stored from the renewable energy sources, there should be virtual databases, so that remotely all the engineers and all the researchers can work. So I am starting from the diagram as user interface layer. So user interface layer, I added web portal, mobile application, or some voice assistant integration. Why? Because everyone have different backgrounds, everyone have different they can provide services from different locations. It is based on their convenience. So there may be many interfaces, but I have considered these 3 interfaces. So after interface, application, like in the core management layer, I added AI optimization engine and authentication main control system. So I want to elaborate this user interface. Yes. So real-time monitoring system we can do if we are extracting any renewable energy source and we are storing that locally. As I said, mobile application or any web development, globally we can, based on how many data centers are there. Real-time monitoring system we can establish in any web portal or mobile application. And yes, in morning session and yesterday session, I have heard from sir that we have to focus more towards safety management also. If any, there may be multiple modes, multiple components, multiple elements. If a small issue comes, we have to shut down entire system for the safety of the huge project. If not, due to the small error, the huge project will get many expensive damages. And yes, I'll come towards the next block, that is data management. Yes, data management. How we are managing our data, how we are clustering different categories of data. After user interface, core management is there. After core management, we have to focus on our data. What particular data, like face detection system, sir, Farooq sir said that previously we are focusing on eyes and what are the important features are there. So in data management for renewable energy sources, some important major data losses, time series database, forecasting system, and weather integration, analytics engine. So based on weather conditions, based on timestamps, and based on like how sudden the rainy season or autumn or sunny season is there, summer season, based on that we are categorizing the data and storing locally. So we can work out in virtual platforms. So after data management, why we are focusing on more on data management, because if we focus more on data management, more better results we can extract. How much detailed data we are gathering, we can do more research based on the data sets. How much detailed data we are extracting from upper sensors or any the extraction of data, we can do more detailed research and get more better results. So after data management, left side one block diagram is there. Yes, different energy storage. This is storage, this one renewable energy sources. We can consider I am more focused towards wind energy because I am doing research on that. That's why there are multiple renewable energy sources, but I have done my project in ad hoc networks. How communication is possible in remote areas, in mountains. So that's why I am focusing towards wind energy system. So after renewable energy sources, energy storage systems. See, I have not make my architecture as, but superficial overview I am giving. I have not done like that research. Yes. So if you observe, the wind turbines store the energy in their turbines itself. If I am correct, based on my research. So battery banks will be present in wind turbines itself. Battery management system. Like how much data, if suppose wind is not that much, it is not rotating the turbines. So there will be some storage to push the turbines of the wind turbines. To take initial start. So like this we can manage our battery banks. Like locally we can store some amount of power, and the rest which can be supplied to other devices we can store in other banks. So next is home management. So home management system I have not. Yes, home management. As we all know, nowadays in all homes AI gadgets are there, like Alexa, and whether it is chimney, whether it is our cooker, most of the things have AI integration in the gadgets, daily home appliances. So we can categorize how much power is utilized in different devices in home itself. Like if solar geyser is there, how much power is consumed by solar geyser. If we are using any specific home automation devices, how much power is used for that home automation devices. And if we are completely occupied with the power, we can store it locally in home. So that like inverters we are using now, like if we are collecting the data from renewable energy sources, we can store locally in our battery banks at home for later use. Yes, I want to conclude because at last we have to focus more towards renewable energy sources, because in our day-to-day life population is increasing rapidly, and because the sources which are used nowadays like petrol, diesel, they are getting decreased in a rapid way. That's why we are focusing towards renewable energy sources and doing lot of research, because government is supporting us to do research in renewable energy source. And I selected my topic as wind turbines, I have worked on wind turbines also. That's why I selected this topic. So, thank you from my side.
Thank you, Amin. So, Amin try to give a very high level understanding in which we can have different renewable energy sources, energy storage, and then he also tried to consider about the user interface, okay, and then of course taking into account some smart gadgets which we can use for our home automation, and within that then how we can do the home energy management system. So, thank you, Amin. So, it's good attempt. Anyone among you want to present something? Please. Yeah, yeah. Yeah, yeah, no problem. No problem, yeah, yeah.